Good morning. I am Renu Sharma, Assistant Professor, EC Department. Today, I am going to start with the next part of unit of this subject, that is data communication network AEC 063, and the topic of today's lecture is cryptography. So, these are the contents of today's lecture, that is cryptography, then components and categories. So, before we will begin before we will begin this lecture, we will think what is cryptography. Now, cryptography is basically, or you can say indirectly, related to the security. So, cryptography is the study of secure communication techniques that allow only sender and interested recipient of a message to view its content. So, basically, whenever we want to transmit any information, let us say in digital information, let us say we want to transmit this 1011, then we want to transmit it from one transmitter to receiver, and there is a possibility that there are intermediate nodes exist. Let us say this is the node which exists, this will be the node which exists. So, it may be possible that this information can be seen by this intermediate node or this intermediate node. So, to remove that situation, to reduce that situation, we uses this cryptography technique, where this particular message is XORed with, or you can say it is modulo 2 added with a PN sequence that is known as pseudo noise sequence. This is known as pseudo noise sequence, and that is randomly generated sequence which is of higher bits, which means let us say this message is of 4 bits, then this PN sequence can be taken as 15 bits, 20 bits and more than that also, and that will act as a key. Like in analog modulation or analog communication, we require a carrier signal, and that same carrier signal has to be used at the receiver side, so that the proper synchronization can be maintained between the transmitter and receiver. In the same way, when we are talking about this digital communication, this modulo 2 addition is to be considered, or is to be done. This step has to be done with the PN sequence and the message sequence, so that the whatever the information which is of higher bits can be seen by the required receiver only. So, whichever receiver is having this key can going to demodulate that signal, or can going to see that what will be the actual information which is contained in the message. So, this is the whole idea behind cryptography, that is strictly used for security. So, earlier cryptography was effectively synonymous with encryption, but nowadays it is mainly based on mathematical theory and computer science practice. So, basically earlier it was used for encryption only, nowadays it can be used for mathematical theory also. So, these are the components of cryptography, like this is the sender that we require, which will going to send the plain text. Now, there are two terms which will be used many times, that will be cipher text and plain text. Now, what is plain text? Plain text is basically means that whatever actual information that we want to transmit, that is known as plain text. In the previous example, I have told you that 1011 I want to transmit. So, that will be the plain text, and whenever it will be encrypted using this PN sequence or pseudo noise sequence, that is randomly generated sequence, it will become a cipher text, which means it is an encrypted version of the original signal. So, that is the main difference between plain text and cipher text, and obviously, the number of bits in the plain text will be less as compared to the number of bits in the cipher text. Now, these are the components. So, first one will be the sender, second is we require an encryption. So, encryption process will constitutes the modulo 2 addition of the input bits with the PN sequence bits. Then cipher text will be generated. Then at the receiver side we require a decryption, and decryption the output will be at the receiver, and the plain text we require. So, so the plain text will be delivered to the receiver side, which is the main aim of this communication. So, these are the basic components of cryptography. Now, next is categories. So, I have told you that PN sequence is required to make the plain text converted into the ciphertext. So, there are two types of keys which are possible, like first one is the symmetric key PN sequence, the other name for PN sequence is the key. So, it can be a symmetric key or it can be a asymmetric key. So, symmetric key means it is a secret key. Now, what is secret key? Secret key is basically the key which is known only by the transmitter and the respective receiver. Let us say there are 3-4 intermediate nodes are there which can also demodulate that particular signal, but that is not possible because the key is secret between the transmitter and the receiver. It cannot be demodulated by any intermediate node. So, that is the main aim of the symmetric key. Next one is the asymmetric key. In case of this asymmetric key, it is using the public key, and that public key can be used by another receiver also. So, this is the main idea behind symmetric key. In symmetric key cryptography, the same key is used by the sender, that is for the encryption, and the receiver, that is for the decryption. The key is basically shared between the transmitter and the receiver. Let us say in this we are taking an example like the transmitter name is Alice and the receiver name is Bob. Then the Alice wants to communicate with the with the Bob, then Alice will going to send a plain text for the encryption purpose, and then the shared key, the shared secret key can be used will be used by the encryption and decryption both at both the sides, same as the analog modulation, where the same carrier signal has to be used between the transmitter and receiver. Then the ciphertext will be created and that will be decrypted using this same shared key, and then the plain text will be delivered to this Bob. So, this is the very basic, or you can say the very simpler method which is the simpler which is the symmetric key method for delivering the message to the using the shared secret key, delivering the message to the required receiver. So, the intermediate node that is not having the same key, that is not having the same PN sequence, cannot demodulate the particular message. Only the respective receiver which is having that same key, that can going to demodulate the signal. Next one is the asymmetric key cryptography. Now, what is asymmetric? In case of this asymmetric, there is an Alice and Bob, the same example we are going to take in this lecture. So, asymmetric key means it will be a public key. So, there will be a key that has been used. You can see over here that there is a Bob's public key and there is a Bob's private key is there. So, the public key means it can be it can going to access this it can going to access the data to another user also, another receiver can also receive that particular data, and the Alice can also use that data. So, that is a Bob's public key, whereas when we are talking about this Bob's private key, then it will be used between the Alice and Bob only. So, there are two types of keys which are available to the Bob, that is private and public key. So, that is the basic difference between symmetric and asymmetric key. Next one is comparison. So, this diagram is showing the basic comparison between symmetric key cryptography, this one, and this is asymmetric key cryptography. Now, you can see that this is the shared key. So, since the Bob is having the same key, so that is why it can going to demodulate the signal, or you can see that it can going to find out that what will be the actual messages. So, this will be the concept of symmetric key cryptography. Next one is asymmetric key cryptography. In this case, the this is the private key and one is the public key. So, whatever Bob is having the private key, it will going to listen the message from Alice only. So, that is the comparison between symmetric and asymmetric key. Now, next is traditional ciphers. So, basically there are different ciphers are there. Ciphers is actually related to the ciphering that is being accomplished using the PN sequence, means we are modulo to adding the input signal with the actual with the PN sequences. So, that is the context of traditional ciphers. So, there are two types of ciphers are there, like first one is the substitution cipher, which is again divided into monoalphabetic and polyalphabetic, where it will be divided into two types. Then traditional cipher is also divided into transposition cipher. So, we will going to see each one in detail in our next slide. So, this is the traditional cipher, means how we can going to add the extra bits or extra data with this ciphering operation. Now, next one is the substitution cipher. This is the first kind of cipher. So, substitution cipher replaces one symbol with the another. So, what does it mean? That in case of the substitution cipher, let us say A is encoded as B. So, whenever the data we will receive as A, it will be before receiving we will be going to change it to B. So, that is the substitution cipher, means we are going to replace that particular alphabet. So, it is of two types, first one is monoalphabetic cipher, second one is polyalphabetic. In case of monoalphabetic, it is any cipher in which the letters of the plain text are mapped to cipher text letters based on a single alphabetic key. So, monoalphabetic means we are changing only one alphabet depending on the criteria that we have considered for the ciphering, for the purpose of cryptography or for the purpose of encryption. So, only one particular alphabet will be changed. So, the example of monoalphabetic ciphers would include the Caesar shift cipher, where each letter is shifted based on a number key, and at Bash cipher, where each letter is mapped to the letter symmetric to it about the center of the alphabet. So, basically it can be, it is of two types again, that is Caesar shift cipher and at-bash cipher. In both are having the different criteria for ciphering. Second type of substitution cipher is polyalphabetic cipher. It is any cipher that is based on the substitution using multiple substitution alphabets. So, basically that is totally different from the monoalphabetic. In case of monoalphabetic, we are changing only single alphabet or we are shifting the alphabets by one position. In case of polyalphabetic, we are changing or we are substituting more than one alphabet. So, this cipher is probably the best known example of a polyalphabetic cipher, though it is a simplified special case. So, that is the polyalphabetic cipher example. Now, we are going to discuss 2-3 examples that how this ciphering is performed. So, first example is that the following shows a plain text and its corresponding cipher text. So, is the cipher is monoalphabetic? So, we have to find out that whether it is monoalphabetic or not. So, this is the plain text, that is hello, and KHOOR, that is the cipher text. So, you can see that H is replaced by K, E is replaced by H, L is replaced by O, and O is replaced by R. So, the cipher is probably monoalphabetic because both occurrence of L's are encrypted as O's. So, you can see that for both the alphabet L, we are changing it by O. So, that means that a single alphabet change is possible in this monoalphabetic situation. So, that is the example which going to demonstrate that what is monoalphabetic cipher text looks like. Second example is the following shows a plain text and its corresponding cipher text. So, it is monoalphabetic, we have to again identify that in this case that H is replaced by A, E is replaced by B, L is replaced by N, another L is replaced by Z, and O is replaced by F. So, you can find out that both these L are replaced by different alphabets. First one is replaced by N, another is replaced by Z. So, which means that it is not monoalphabetic, it is a polyalphabetic. So, cipher is not monoalphabetic because each occurrence of the letter L is encrypted by a different character, and the first L is encrypted as N, and what I have told you that if the same letter is encrypted by another by different alphabets, then it is polyalphabetic, otherwise it will be a monoalphabetic case. Now, next is transposition cipher. So, what is transposition cipher? You can see this is the plain text, or you can say it is the transmitter side and this will be the receiver side. At the transmitter side there is a plain text which is being let us say it is example is Alice, Alice is the transmitter and Bob is the receiver, which we have taken in the previous slides also. So, it will going to generate a plain text that will be generated in terms of blocks, then it will be reordered. Then so, what type of reordering will be done for the encryption purpose? Let us say the first alphabet will be 1, this one is second alphabet, this will be the third, this will be the fourth one. So, in case of this encryption, you can see over here that first letter will be written over here, second will be written over here, third will be written over here and fourth will be written over here. So, this pattern, first thing is that you have to keep in mind that in case of transposition cipher, this pattern is not fixed. You can change it depending on your needs, depending on the application you can change, but this is the transposition cipher. So, let me take an example. Let us say I want to transmit this 4 letter word, that will be HELO. So, this is a 4 letter word. So, this will be the first alphabet, this is second one, this is third one, this is fourth one. So, depending on this diagram whatever it is written. So, first alphabet has to be written over here, second alphabet has to be written over here, is then third one is this one and fourth one is this one. So, this will be the cipher text and the previous one will be the plain text. So, this is how you have to operate, you have to generate this transposition ciphering, you have to use this transposition ciphering using this criteria which you have drawn using these lines. So, this is the process which is been followed over this. So, this will act as a key only, because it is your decision that the first alphabet has to be written over here, second one is to be written over here, third one and there is a fourth one. So, this is your decision. If someone else, if the third party know this decision or the third party know this type of key that will act as a key, then it will going to demodulate the signal, because at the receiver side the reverse part has to be done, then this has to be delivered to the receiver, which is the plain text. So, this whole thing is known as key. So, that is the transposition cipher. Now, the next one is the P boxes. So, basically P boxes is a kind of is a type of transposition cipher only. So, there are P boxes is of different types, like first one is the straight P box, second one is expansion and third one is the compression. So, in this case, like the first one straight, you can see that only single letter, let us say it will be A, P, P, L, E. We have used a word that is apple. We can use any 5 letter word and we want to perform this straight ciphering. So, how do we have to perform this straight ciphering? Now, you can see over here that first letter has to be written over here. So, here we write A, second letter has to be written over here. So, this is P, third one is here, fourth one is here and fifth one will be here only. So, this is the straight form of transposition or the P boxes ciphering, which is the general form of transposition cipher. The second one is the expansion one. Now, you can see over here that the first one, that there are initially 5 alphabets are there and it will be extended to 5 alphabets. So, that is the expansion type of ciphering. In this case, let us say it is a 3 letter word, let us say it is a CAT, cat, we have taken as an example. Then at the output side, or you can say after ciphering, it will be converted to 5 letter word. So, how we have to convert? Like first one, first letter is C. So, here we have to write C and here we have to write C again. Here we have to write A and this letter will be repeated as this one. So, the cipher text will be CTAT, that will be CTACT. So, this is the initial one plain text and this will be the expanded P boxes or the expanded cipher text. So, that is an example of expansion. Second one is compression, which is the reverse part of this expansion. You can see over here that there are 5 letter words are there at the initial stage and it will be converted into 3 letter cipher text. So, let me take an example, let us say it will be APPLE, we have to convert it into 3 letter words. So, second we want to take, so that will be P, then this will be P and this will be L. So, this apple will be changed to PLP. So, this is the compression one. So, you can see in both the cases, if you know this actual key, these 3 boxes are actually the key. Whichever intermediate node or whichever receiver is having this type of key, only they can demodulate the message. Let us say I receive this one and I have this block diagram, then I can convert it into this letter, that is cat. Same is here also, whichever user is having this type of key, that is for the compression, it will going to convert this PLP into apple, that is the required information. So, that is the case, this is the transposition cipher. So, in this lecture we have discussed about cryptography, where different two types of keys we have considered. Like first one is the symmetric key. I will show you. Symmetric key is basically, because it is somewhat confusing only. In case of this symmetric key, a single shared key has to be used between the transmitter and receiver. It should not be used by the intermediate node. In case of this asymmetric key, there are 2 types of keys. First one is the Bob's key, that is public key, another is the private key. So, basically 2 keys are there. Public key can be shared by any other user, any other third party, whereas private key has to be used with only one transmitter. So, that is the difference between public and private key. Then we have seen the comparison, where you can see that the same key can be used for the symmetric, and in case of asymmetric, the private key can be used for the receiver side and public key can be used at the transmitter side. Then we have seen the traditional ciphers, where different types of cipherings are there, and this will act as a key only. Whichever user is having that same key will going to demodulate that particular signal. In case of substitution, we are going to change the alphabet, means let us say 5 alphabets are there at the initial stage and the 5 alphabets will be delivered or will be achieved at the receiver side also. There is no change in number of alphabets, whereas in case of transposition cipher, it will somewhat a different scenario, where this type of changing of places will take place, and it is of 3 types. First one is straight one, where n number of input are there and n number of output, whereas in case of expansion, the number of output alphabets will be increased as compared to the as compared to the transmitter side, whereas in case of this compression one, the number of alphabets has to be reduced. So, this is the example that is related to this P boxes. So, this cryptography, the basic advantage of this cryptography is for the purpose of security only. That is the initial stage why we have this cryptography was designed, which have used this PN sequences. So, basically PN sequences is of 2 types which can be generated, like first one is the gold sequence and second one is the Walsh matrix. So, these are the 2 methods by which you can generate the PN sequences. Now, these gold sequence is basically a kind of generator of n number of bits which we want to transmit, but in case of Walsh matrix it is totally different. It is a kind of matrix. Let us say it for W1 it will be a 0 only, and for W2 it will be 4 bit of information, that will be this one, and this particular matrix can be increased n number of times. Let us say for W 4 it will be increased 4 times. So, that it will be repeated 4 times. So, that is the main idea behind Walsh matrix. So, this is about the PN sequence and this is all about cryptography. These are the references that you can go through for this particular topic. Thank you.